3x in 1.1.1, essentially we would say 3x minus 6 is equal to 0, or x plus 2 equal to 0. So then on this first one here, I would take negative 6 to the other side. So now I have 3x is equal to 6. And then I would divide both sides by 3, like so. And then this 3 and this 3 cancel. That's 1, 1. So, and I know 3 into 3 is 1, 3 into 6, that's 2. So x is equal to 2. And then for this one, I would simply transpose 2 to the other side, or take 2 to the other side of the equal sign, and that becomes x is equal to negative 2. So that's the solution of 1.1.1. And for 1.1.2, you have a quadratic equation, and it says they are correct to 2 decimal places. So usually when it says correct to 2 decimal places, for me it tells me that I should use the quadratic formula. So my equation says 2x squared minus 6x plus 1 equal to 0. And I know that the general form of a quadratic equation says that ax squared plus bx plus c equal to 0. And I know that so in my particular case here, a is 2 and b is negative 6 and c is 1. So I'm just going to lay that out here. A is equal to 2, b is equal to negative 6, and c is equal to 1. And for b here, which is negative 6, it's very important that if it's negative like this, I have to take it as a negative 6. If I leave out this negative, then there will be problems now when I substitute into my formula. So we know that the formula says that x is equal to minus b, or negative b, plus or minus the square root of b squared minus 4ac, and all of this over 2a. So then I then come to this formula and substitute all these values. Where there is a, I'm going to put this. Where there is b, I'm going to put this. And where there is c, I'm going to put this. So substituting that, x is equal to, there is this negative from the formula, but remember my b itself is negative, so I have to have negative 6 here. I'll put it in brackets like this, and then plus or minus the square root of b squared, so that's negative 6 squared, minus 4 so a is 2 and c is 1, and then all that over 2 by a, which is 2. So I've substituted everything into my formula is shown here. Then I would go ahead and simplify things. So minus 6, that's positive 6, and then I have plus or minus square root of negative 6 squared is 36, positive 36, and then minus 8, that's 4 by 2, 8 by 1, 8. All of that over 4 from 2 by 2 times 2. So I'm just going to go ahead and punch that into my calculator to see what the two values of x I get. So I would start with the plus part. So I'm just going to go ahead and punch my calculator. You can also punch with me. If you're following along, it helps you to be a bit involved in the work. And then, so from the plus part, when I say 6 plus square root of 36 minus 8 all over 4, it gives me 2.82. So that's the first value I'm getting, 2.82. And then I would change the plus to minus to get the other value. It's giving me, it says equal to 0.18. 0.18. Like it says here, it says 2 decimal places, so I have to round off my things here to 2 decimal places. All right. So then moving on to the next question, that would be 1.1.3. Now for 1.1.3, I have, it says here, just erase that. So it says here x squared minus 90 greater than x. So essentially I would treat it almost like a normal quadratic, because I can see it's a quadratic inequality here. So I would say x squared, then I would bring x to this left hand side, then it becomes minus x, and I have minus 90. Now it becomes greater than 0 because there is nothing left on the right hand side because I moved my x to the left. So essentially I would go about factorizing this left hand side. So if you don't know how to do that, I would suggest maybe one approach which I normally use. So I have this, I multiply the first, which is x squared, times the last, which is negative 90, so it becomes negative 90 x squared. That is negative 90 multiplied by x squared. Then I go about finding basically two factors which, if I multiply them, like I'm gonna just put a box here and I say multiply by, so there are two factors which I multiply and they give me this negative 90 x squared. And then if I add those same factors, if I add them this time, add them together, I would get this middle term, in this case, which is negative x. So if I add, it should give me negative x. So then if I don't know immediately, I can do trial and error, which is trying certain numbers to see which two numbers do I multiply to give me negative 90. And if I add them, they give me negative 1. So I can see that I can take negative 10x and 9x. Negative 10x and 9x. Essentially, if I say negative 10x multiplied by 9x, I should get negative 90x squared. If I say negative 10x plus 9x, I should get negative x, like this. So then my my pair of factors which I was looking for was this one. So then what I'm circling in red here, that's what I would replace the middle term, which is negative x by. So here's how I would do it. So I would take the first one, x squared, as it is, so x squared, and then I would replace the middle term, which is negative x, I would replace it by negative 10x plus 9x. It becomes negative 10x plus 9x. And then the last term would be still negative 90. So the only thing that has changed is the middle term, greater than 0. So I'm factorizing here. Now I have 4 terms. 1, 2, 3, 4. So then I deal with those terms in pairs. So like I have this pair, I have to factor out the common factor there, and I have this pair. So if I can look at x squared minus 10x. The common factor there is x, so I factor out x. So that gives me x minus 10 in brackets, right? Essentially, if I divide x squared by x, I get x. If I divide negative 10x by x, I get negative 10. And then I am going to also factor out something on this pair of terms. But whatever it is that I'm going to factor out, it should give me the same thing in brackets. So this set of brackets should have the same thing as this set of brackets. So I should have also x minus 10, the same thing in the brackets. Now I have to figure out what do I factor out here to give me the same thing. So if I don't know exactly how to do that, then I try some numbers to see what should I factor out. What do I divide 9x by in order to get x? So I would eventually see that I have to factor out positive 9. Because if I divide this by positive 9, I get x. If I divide this by positive 9, I get negative 10. Greater than 0. Let's not forget that. Then I'm going to bring together these terms that are outside of the brackets into one set of brackets. So x plus 9. And then I take the factors in brackets. That's x minus 10. Greater than 0. So my factorization is essentially complete there. Now, what I'm going to try to do then is I'm going to try to sketch the curve for this quadratic, right? So because I can see here that the coefficient of x squared is positive. So the coefficient of x squared is positive. So that means that it's going to be a smiley face, right? So something like this. Yeah, so I'm just gonna put in some x's in there. Yeah, it's not very straight, but that's okay. So then what this essentially is the curve. So that's just a rough sketch of the curve. So what I'm gonna do then is I'm gonna locate these. So the critical values here will be, I take this one, I say x plus 9 equal to 0. And then also I take this one, x minus 10 equal to 0. And then solving this, x will be equal to negative 9. And also solving this, x will be equal to positive 10. So if I put that, this point here is essentially the negative 9. So I'm going to put negative 9 there. And this point here, the 10 will be here. So that will be 10. Those are the critical values that we need to locate in our situation here. So then we can see that all of this is said to be greater than 0. Greater than 0, we are talking about positive y, right? Positive y values. So essentially, which part of the function here would give me, would have positive y values? So essentially, what I'm looking for there is the part of the graph which is above the x-axis. So I know this is my x-axis, this is my y-axis, right? So the part of the graph which is above the x-axis, of course, is this part here. This part is above the x-axis, and from this point up there, this part is above the x-axis. So the corresponding x values for this part of the curve and this part of the curve, for this side, I would be starting from here, going all the way to the right. And then I would be starting from here to go all the way to the right. I mean to the left. So because anything other than this and that, like for example, if we just look at maybe this point of the curve, this point of the curve, is a different. So this point of the curve, the x value or the x value will be here, but the y value will be negative. It's below the x-axis. So any point on this part of the curve, any point on this part of the curve would give me values of y that are less than 0, but I need greater than 0. So I need these parts of the graph that are above the x-axis. So that's why I take this range of values and that range of values. So now just writing that now in as an inequality. So this range, the range to the left of -9, will be x is less than -9, because I know all the numbers that are to the left of -9 are less than -9. And then also for this part to the right of 10, as an inequality, that will be x is greater than 10, because all the numbers that are to the right of 10 are greater than 10. So those would be my solutions for this one. So now going to 1.1.4, I'll just erase this here. Now 1.1.4. So it says x minus 7 root x is equal to -12. So for this one, there are several approaches we could use, but the approach that I'm thinking of using is taking -7 root x, and this whole unit should move together because it's bound together by multiplication. So -7 root x is one entity. So I want to move it to the right hand side and then move -12 to the left hand side. So like so, x, then -12 when it comes to this side, it becomes plus 12 is equal to, and -7 root x when it comes to the left, I mean to the right, it becomes 7 root x. And then so the first thing I want to do is I need to deal with this square root. I need to get rid of this square root somehow. So the best way to get rid of the square root is to square. So basically I'm going to square both sides. So I'm just gonna say x plus 12 is equal to 7 root x. So I square both sides like so. Now for this side, when I square like that, just so that if anyone has a bit of a trouble like expanding this, it's essentially x plus 12 x plus 12. That's what x plus 12 squared is. And then what then we do is we need to, for this one we square 7, so 7 squared, essentially this would be 7 squared, and then square root of x squared. So the squared, or the power 2, affects both 7 and root x. Then here, of course, x by x, that's x squared. Then x by 12, that's plus 12x. And then 12 by x, that's plus 12x. And then 12 by 12, that's plus 144, equal to 7 squared, that's 49. And then square root of x squared basically is x, because if I square a square root, then it's almost like the square root disappears, if we could loosely say that. And then x squared plus 24x plus 144 is equal to 49x. Then of course I'm gonna collect everything to one side, then I can solve it as a normal quadratic. So I'm going to bring 49x to the left hand side. So that's x squared plus 24x minus 49x, because it becomes negative when I bring it to the left, plus 144 is equal to 0. There's nothing left on the right when I move 49. So then this becomes x squared, and 24 minus 49, that's negative 25, negative 25x plus 144 equal to 0. So again, I have to look for factors which can replace negative 25x. So like I did before, I said 144 multiplied by x squared, that gives me 144x squared. So then I have to look for factors which give me if I add them, they give me negative 25. If I multiply them, they give me 144. That the factors would be 9 and 6. So that would be negative 9 and negative 16. So we'll see that the factors would be negative 9 and negative 16. So I would say x squared minus 9x minus 16 x plus 144 is equal to 0. Then now I have 4 terms. So with these 4 terms, I then factorize this way. So here on the first 2, I factor out x, which is the common factor. So that gives me x minus 9. And then I have to get the same thing in brackets as x minus 9 when I factor out here, equal to 0. So if I look at this, I would see that it's negative 16. That is the factor which gives me x here and negative 9 there. And then x minus 16, I bring together what is outside the brackets, and then x minus 9 is equal to 0. So then solving this, it's x minus 16 equal to 0, or x minus 9 equal to 0. So that gives me x equal to 16 or x equal to 9. So that would be the solution of this this question.